Example 8.3.3. All right, we're going to actually go through this one because there are a number of moving pieces to this one. We're combining a lot of parts from the previous two examples into this one, so we'll actually work through it together here. The setup for this one says, suppose you're considering buying a stock. You expect the stock to pay a dividend of $5 1 year from today, $5.50 2 years from today, and then the dividend will grow 2% each year after that. Using the CAPM, or capital asset pricing model, you estimate your required return at 10% to compensate you for the risk of this stock's cash flows. What is the maximum price you are willing to pay for a share of this stock? All right, we have a time value money problem, so we're going to do our three-step process where we're going to start by mapping the cash flows out. We're looking for the price we would be willing to pay today, and this is another dividend discount model because we've got dividends that we can project, and we're going to discount them back to today's price using our risk-adjusted discount rate. So we know we're going to be looking for present value. All right, we know that the discount rate we want to apply is 10%. Using that rate as the discount rate will give us the maximum price that we can pay and still earn 10% on the expected future cash flows. All right, we expect that 1 year from today, the stock will pay a dividend of $5. We expect that 2 years from today, it'll pay a dividend of $5.50. And that is as far out as we're going to project specific dividends. At this point, starting right here, we're going to assume that it just takes on a set growth rate, that's a little g, of 2%. And this $5.50 dividend is just going to grow by 2% each year after that. So if I want to know the dividend at the end of year 3, I would take that $5.50 dividend from the end of year 2, and then I would multiply it times 1 plus the growth rate to grow at 2%. So I'd multiply it times 1.02 to grow it. Okay? Once we hit this growth rate, we have a growing perpetuity. All right? So starting at the end of year 2, we get that last specific dividend. Now we've got a growing perpetuity going on into infinity. All right, so this pattern would just go on, and we don't have to project any more cash flows because we know how to deal with that. We can use the present value of a perpetuity formula and find the present value of this thing. All right, so there's a bit of a wrinkle here, though. What we've got here are two specific cash flows, the $5 and the $5.50. Those guys are just sort of unrelated cash flows. It's one or the other, or maybe you could say it's a 10% growth rate between year 1 and year 2. That's not going to save you a whole lot. We'd have to, if we wanted to call it a growing annuity, we'd have to use the present value of a growing annuity formula, which is going to be a lot more difficult than just treating each one of these guys as a lump sum. So for our dividends, identifying the type of cash flows that we're looking at from time period 0 out to the end of year 2, we're just going to call these lump sum cash flows. All right, this $5 and this $5.50, we're just going to treat them like lump sums. So dividends 1 and 2 are lump sum cash flows. And then starting right here at the end of year 2 or the beginning of year 3, we begin a growing perpetuity. So dividends 3 through infinity. 3 through infinity. Just pretend that's an infinity symbol. Are a growing perpetuity. All right, we have different tools that we use to evaluate these two different cash flows. With the lump sum cash flows, we can use the present value of a lump sum formula. We could use time value money keys in a calculator, or we could use a spreadsheet to find, in each case, what we're going to do is take each one of these cash flows and discount them back to time period $0. including the growing perpetuity starting at the end of year 3. We'll talk about that a little bit more in just a second. But for these first 2 dividends, we've got those 3 tools available to us: the present value formula for a lump sum, or the time value money keys on a calculator. We'll probably just go straight for the formulas on this one since there's 2 of them. Or I guess we could use the cash flow worksheet as well. That just sounds like more work than just doing the formulas. The wrinkle we hit here with the growing perpetuity formula is, let's take a look at that formula real quick. The present value of a growing perpetuity. And I'm going to say we want the present value. Well, let's look at the general formula first. The formula says the present value of a growing perpetuity at time period t is equal to the cash flow at time t plus 1, right? So 1 period later, divided by the discount rate minus the growth rate. The timing on this matters. When we plug in cash flow at t plus 1, which for us is going to be the first cash flow of the growing perpetuity, the one that begins it. That's going to be this $5.50 times 1.02, whatever that comes out to be. In fact, let's just go ahead and calculate that so we're not confused. $5.61 is what that comes out to. So the dividend at the end of year 3 is going to be $5.61. That is our cash flow at time t plus 1. So let's fill this thing out for that actual cash flow. For us, that $5.61, that happens at the end of year 3 on our timeline, right here. So if we were to plug in actual numbers instead of variables to our general formula, that's cash flow 3 that we're plugging in. That means we're getting the present value of this perpetuity 1 period before that. It's going to be at the end of year 2. So let's actually calculate this, and then we'll throw it up on the timeline. Our discount rate is 10%, so 0.1, minus our growth rate is 2%, so 0.02, expressed as a decimal. And let's plug that in, see what we get. Divided by, parentheses matter here because we want it to do the subtraction before the division, so I'll say open parentheses, 0.1 minus 0.02, which is of course going to be 0.08. And when I hit equals, it'll go ahead and do that division. So that is $70.08. And I'm going to go ahead and retain that. I'm not going to round it to the nearest penny yet because we're not quite done with this, and I want to reduce rounding errors as much as possible. Okay, so the present value of dividends 3 through infinity is $70 and about 13 cents. Right? So if we were to put this back up on our timeline, what we did is took this infinite stream of cash flows and we found the present value of it, but we found the present value as of end of year $2. Right? So it goes right here on our timeline. Before we can say what the intrinsic value of this stock is, we need to first get this $70 and roughly 13 cents back to time period 0, right? Because it's an end of year $2 right now. And we also still need to find the present value of these 2 cash flows, the $5 1 year from today and the $5.50 2 years from today. All right, so we've got a couple of tools to do that. I'll write out the formulas and I'll show you a kind of a calculator shortcut you can use for this one. It's using the time value money keys. You'd have to do the $5 by itself, then you could add these 2 at the end of year 2 together and do it, but you'd have to calculate present value twice and then add those together, which we'll see in the formulas here. So let's just say now the present value as of 0 for this infinite stream of cash flows is going to be, I'm just going to use, well, it's the general present value formula. It's equal to the present value. Present value is equal to future value times 1 plus r to the n. So this is the lump sum present value formula. Right? So we can use that and calculate the lump sum for all of these dividends. We've got the $5 dividend at the end of year 1. So we want to divide that by 1 plus r. Our discount rate is 10%, so that's 1 plus 0.1, which is going to be 1.1. That $5 cash flow happens at the end of year 1, so our exponent in the denominator is just 1, or we can leave it blank. All right, we want to add to that the cash flows that happen at the end of year 2. Now, both of these happen at exactly the same time. They're both in end of year $2, so it's perfectly fine to combine them rather than treating them separately. So we're going to say $5.50 plus $70.125. That quantity, once those are added together, divided by, again, 1 plus r raised to the n. Our r is 10%. So 1.1. Both of these happen at the end of year 2, so we need to square that discount rate in order to bring it back 2 periods. Right, so we can, I guess we can just go ahead and calculate that real quick. It'll only take a second, and then I'll demonstrate using the cash flow worksheet for this, which is probably the fastest way to go. All right, so I'll start with the second one since it's already in there. 70.125 plus 5.5 equals, I want to make sure it does that addition first. And I'm going to divide that by 1.1 squared equals, all right. So the present value of dividend 2 plus 3 through infinity as of time period $0 is $62.50. And then the present value of dividend 1 is 5 divided by 1.1, so we're just going to reduce it 10%. 4.545, and that's going to keep on going for a while. We'll just leave it at that. All right, so I'm going to use, while this is on the display, I'm going to go ahead and add it to the value I stored earlier. That one's even, so it doesn't really matter. And that'll give me a pretty precise answer. So the present value of this thing as of time period 0 is about $67, and now we'll round it to the nearest penny, 5 cents. All right, so 67.05. So if we're going to put that on the timeline, it would go up here. All right, before we talk about what that means, let's look at a quick calculator shortcut. And here, actually, I'll leave it on the timeline. That'll probably make more sense. I'm going to use the cash flow worksheet to plug these in because it can deal with lumpy cash flows. Of course, the last problem I worked is still in there. So I'm going to hit second and clear work to zero everything out. And again, to open that up, I just hit the CF button that's right next to your second key. CF0 is what cash flow do you experience at time period 0. Well, that's actually what we're trying to calculate, so we're going to leave that guy blank. We're going to leave it at 0. Hit the down arrow key to go to cash flow 1. That's a cash inflow of $5. It happens at the end of year 1. So type in 5 and press enter. And then I'm going to hit the down arrow key. It's going to ask for FO1. That's the frequency of cash flow 1. How many times in a row do I receive that $5? Well, in this example, it's just once, so I'm going to leave it set to the default 1 and hit the down arrow key to go to the next entry. Cash flow 2, now, that is what cash flow happens at the end of year 2 or at the end of period 2. That is the $5.50 plus the $71.25, right? And it's important to note that, of course, you don't receive a check for $70.13 here at the end of year 2. What that represents is the present value as of the end of year 2 for dividends 3 through infinity. All right, so we've just collapsed this down to a single value and express it in end of year $2. It's not an actual cash flow that you would receive. All right, so for cash flow 2, I'm going to take that $5.50, and I'm going to add to that the $70.125 equals. Okay, so there's our total cash flow for the end of year 2, and I'll hit enter to store it. Just make sure I remember to hit enter on the first one. Right, and then that's it. We've entered all of the cash flows because we collapsed dividends 3 through infinity down to one single value here. These 3 values represent the infinite stream of cash flows that we are anticipating. So we've got them all entered into the cash flow worksheet now. I like to hit the down arrow key a few times just to make sure there's nothing else in there, and it pops back to the beginning of the menu. It did. That's good. Now I want to know the present value of this. So in the cash flow worksheet, I get that by pressing the NPV key. And it's going to come up with I equals. This is the discount rate that you want to apply. And this is expecting everything in percentage format, not decimal. So for 10%, we'll actually type in 10 and press enter. And then we can hit the down arrow key to get back to NPV. Now we've got the compute prompt up there. It's telling us it's got enough information to calculate it, and it will when we hit the compute button. All right, so we come up with that same value of $67 and roughly 5 cents once we round it to the nearest penny. So up to you if you want to go with the formulas, or you could do this exact same thing with the time value money keys. If I were going to go for the calculator, probably the cash flow worksheet is where I'd go, just because it would be the quickest, and I wouldn't have to. If you use the time value money keys, you'd have to calculate the present value of this $5, store it, and then you have to calculate the present value of this 550 plus 70.125, and then add that value to the present value of the $5 together. So it's just one more step where things can go wrong. I like to simplify and remove myself as part of the equation anytime I can, because I can punch something in wrong, I can pull up the wrong value. There's all kinds of errors that I can make from having to add things together. So if I can get the calculator to do a little more of that, it reduces the likelihood that I'm making errors. Okay, so real quick, what does this value mean, this 6705 that we just came up with? This is the present value of the expected future cash flows at a 10% discount rate. So if we were to actually buy this share of stock for $67.05 and then actually receive these projected future cash flows, our rate of return would be 10% on that investment. And since we estimated that 10% using the capital asset pricing model, that 10% represents the minimum required return that we want in order to compensate us for the risk we think is inside of these cash flows. So if we were to pay anything more than $67.05, right, we would take the $67.05 is not necessarily what price the stock is trading for. It's what we think it is worth, or what it should be worth. So we would take this value and we would compare it to what the actual price is. We pull up a quote and see. If it was anything less than $67.05, and we bought it, then we would expect to earn a return higher than 10% on that stock, assuming our projections for dividends are correct. If the stock were trading for anything more than $67.05, and then if we bought it when it was priced more than that, we would earn a return lower than 10%, which would not be enough to compensate us for risk. Right? So that's what we call this the intrinsic value of the stock. That's what we get out of the dividend discount model. That's what we think it's worth, and then we go out and compare that value to what the stock is actually trading for, which again we'll do in examples coming up next.